Hello students, welcome back. So we are doing logarithms exercise 8D, isn't it, from ICSE book of class 9, and we have completed till question number 15 in our previous videos. So today in this video we'll start right from question number 16 and we will complete this chapter in this video. Okay, so let's begin. This is question number 16. If a square equals to log x, b cube equals to log y, and a square upon 2 minus b cube upon 3 equals to log c, find c in terms of x and y. So these three are the given conditions. We are asked to find c in terms of x and y. Okay, so let's begin. Let us copy this equation. Since given equation is a square upon 2 minus b cube upon 3 equals to log c, isn't it? So this is the given equation. Now we will put the value of a square and b cube. Okay, a square is given to us, that is log x, and b cube is log y, isn't it? Or instead of a square means log x. Instead of a square I can write log x, okay, upon this 2 is in the denominator, minus instead of b cube I can write log y. So log y upon 3 equals to log c is in the right hand side, isn't it? Or let us take the LCM of the denominators. The LCM will be 2 into 3, isn't it? That is 6. Now 2 3s are 6, so 3 into log x, 3 log x, this minus we write here. 3 into 2 is 6, so 2 into log y, 2 log y equals to log c. So this is log c, isn't it? Now we cross multiply this 6 to the right hand side. Okay, 3 log x, we can write this as 3 log x minus 2 log y equals to 6 into log c, 6 log c. Or 3 log x means log x cube, this 3 is raised to power here, okay, minus 2 log y is log y squared, this 2 is raised to power, equals to 6 log c means log c raised to power 6. Now we have log m minus log n means log m minus log n means log m upon n, isn't it? So we can write this as log m is x cube upon n is y squared, so equals to log c to the power 6, isn't it? So we don't have base mentioned here, that means we can assume the base is 10. Okay, log x cube upon y square to the base 10 equals to log c to the power 6 to the base 10. So we can leave log from both the sides and write, let me continue here, or x cube upon y square equals to x cube upon y square equals to c to the power 6. Okay, or this 6 when we bring to the left hand side becomes 6th root. Okay, 6th root of x cube upon y square equals to c. Therefore the value of c, we were asked to find the value of c, isn't it? So value of c equals to 6th root of x cube upon y square. So this is the value of c. Okay, I hope you got this. If we have a square equals to a, then we write this as x root a, isn't it? A square when we take to the right hand side becomes a square root. Okay, similarly if we have x cube equals to a, then we take this cube to the right hand side and write cube root of a. Okay, similarly if we have x to the power 4 equals to a, then we write this as 4th root of a. 4 when taken to the right hand side becomes 4th root, okay, power. Similarly 6th root c to the power 6 becomes 6th root of this, okay, x cube on y square. I hope you got this. Now let us move on to the next question. Okay, now let us do question number 17 from exercise 8D. Okay, given x equals to log 12 to the base 10, y equals to log 2 to the base 4 into log 9 to the base 10, and z equals to log 0.4 to the base 10. Okay, so we are asked to find number 1 x minus y minus z, and number 2 13 to the power x minus y minus z. Okay, so let us do this question. X minus y minus z, isn't it? So we put the values of x, y and z. Okay, so this equals to, what is x? X is log 12 to the base 10. Instead of x, I write log 12 to the base 10 minus, okay, minus, what is y? Y is log 2 to the base 4 into log 9 to the base 10. Log 2 to the base 4 into log 9 to the base 10. Okay, minus, again minus, we have minus z, isn't it? So z is log 0.4 to the base 10, isn't it? So we have this 2 as base 10, isn't it? This also, but this number is being multiplied with this number, so we cannot touch this right now. Okay, so this number and this numbers are separate to each other. So log 12 to the base 10 and log 0.4 to the base 10, same base, isn't it? So this we can write this like this, log m minus log n, isn't it? So we can write this as log m upon n. What is n? 0.4, isn't it? Log m minus log n is log m upon n to the same base, that is base is 10, isn't it? Log 12 to the base 10 minus log 0.4 to the base 10 is log 12 upon 0.4 to the base 10 minus, okay, so this is log 2 to the base 4, we copy as it is, log 2 to the base 4. Okay, now this is 9, isn't it? 9 means 3 squared is 9. 3 squared is 9. So squared we bring here this 3. For the time being we write as it is, okay, into log 3 squared to the base 10. 3 squared. Okay, now we remove the decimal point from the denominator and introduce a 0 in the numerator. Okay, this decimal point is removed from the denominator. Decimal point was before 1 digit, isn't it? So we introduce 1 0. Okay, now 4 1s are 4, 4 3s are 12, and 4 0s are 0. So log 30 to the base 10, isn't it? We removed a decimal point and introduced a 0 in the numerator, and after that 4 1s are 4, 4 3s are 12, 4 0s are 0. So log 30 to the base 10 minus this 2 can be written here, isn't it? Or you can write this number here, 2 log 2 to the base 4 into log 3 to the base 10, okay, or log 30 to the base 10, not or, okay, equal to log 30 to the base 10 minus, so 2 you can write here as power, log 2, this 2 is raised to power here, to the base 4 into log 3 to the base 10, or log, this is not or, equal to log 30 to the base 10 minus log 4. 2 squared means 4, isn't it? Log 4 to the base 4 into log 3 to the base 10. Now log 30 to the base 10, log 30 to the base 10 minus log 4 to the base 4 is 1, isn't it? Log of a number with same base is always 1. Log 4 to the base 4 is 1, which means 1 into log 3 to the base 10, that is log 3 to the base 10. This is 1. 1 into log 3 to the base 10 is log 3 to the base 10. Now we can write this as log m minus log n, because both of these logs have bases 10, isn't it? Log 30 to the base 10 minus log 3 to the base 10. So bases are equal. Log 30 to the base 10 minus log 3 to the base 10 can be written as log m upon n. This equals to log 30 m upon n upon 3 to the base 10. So 3 1s are 3, 3 10s are 30. This gives us log 10 to the base, 3 10s are 30, isn't it? 10 to the base 10. So log 10 to the base 10 means 1. Log of a number to the same base is always 1. So log 10 to the base 10 is 1, and this is the answer for question number 1. Okay, x minus y minus z is 1. Now let us do question number 2. So we are asked to find the value of 13 raised to power x minus y minus z, isn't it? X minus y minus z. So 13 raised to power x minus y minus z is actually 1. So instead of this we can write 1. So 13 to the power 1 means 13. So this is the answer for question number 2. Okay, I hope you got this. Now let us move on to the next question. Question number 18. Solve for x. Log 15 root 5 to the base x equals to 2 minus log 3 root 5 to the base x. This is the equation given to us. We are asked to find the value of x. Okay, so let us copy this equation first and then we will proceed. Log 15 root 5 to the base x equals to 2 minus log 3 root 5 to the base x, isn't it? So this is 15 into root 5, isn't it? 15 root 5 means 15 into root 5. Okay, 15 root 5 means we can write this as 15 into root 5. 15 into root 5 gives us 15 root 5. 15 into a gives us 15a. In the similar way, 15 into a gives us 15a. In the similar way, 15 into root 5 is 15 root 5. Now, so log a into b to the base x means log a plus log b, isn't it? So log a plus log b. Okay, base is x. Base should remain same. Okay, log a into b equals to log a plus log b to the same base x. Okay, equals to, we have 2 in the right hand side minus. Okay, so log 3 into root 5 means log 3 into root 5 means log 3 plus log root 5 to the base x. Log 3 to the base x plus, into means plus log root 5 to the base x. Okay, or log 15 to the base x plus log root 5 to the base x equals to 2. Let us multiply with minus sign. Okay, minus into plus, minus log 3 to the base x minus into plus minus log root 5 to the base x. Okay, now let us bring these two numbers to the left hand side and keep this number 2 in the right hand side. Okay, so log 15 to the base x, now this is log 3 to the base x, we bring first. Okay, minus log 3 to the base x is plus log 3 to the base x. Now plus log root 5 to the base x plus log root 5 to the base x, we bring this number now. Okay, minus log root 5 to the base x means plus log root 5 to the base x equals to, we have 2 in the right hand side, isn't it? So when we bring this number to the left hand side, the sign changes to positive, minus becomes plus. Okay, so this is log m plus log n, same base x, isn't it? Log m plus log n is log m into n. So log 15 into 3, 15 3s are 45, isn't it? X. Okay, plus log root 5 plus log root 5, same base, isn't it? That means log root 5 into root 5, root 5 into root 5 is 5. Okay, root 2 into root 2 equals to 2, root x into root x equals to x, root 5 into root 5 equals to 5. Okay, similarly log m plus log n means log m into n, that is root 5 into root 5 is 5 to the base x equals to 2. Now we have log m plus log n again, isn't it? Same base x, base should be equal. Okay, this means log to the base x 45 into 5, isn't it? So 5 5s are 25, sorry, we need to write 5 5 5s are 25, 5 5 4s are 20 plus 2 is 22 equals to 2. Now this is a logarithmic equation. Let us convert this into exponential form. Okay, so log 225 to the base x equals to 2. That means base is x, so x we write here as base, this 2 we bring as power, equals to 225. 225, isn't it? This 225 goes to the right hand side, or x equals to, this square goes to the right hand side and becomes root 225. Okay, so now our x equals to square root of 225 is square root of 3-digit number is always 2-digit. Okay, so that is we make the pair from the last this. Okay, so 2-digit, so a square number, perfect square number close to 2 or less than 2 can be equal to 2, less than 2 but not greater than 2. Okay, so 1 1s are 1, 2 2s are 4, isn't it? So 1, obviously 1 1s are 1, the first digit is 1 and the last digit is 5. If the last digit is 5, straight away we write 5. Okay, like square root of 6 to 5, the close square of 6 is 2 2s are 4, isn't it? 2 2s are 4, 3 3s are 9, 2 2s are 4, 3 3s are 9. If we go for 3, that becomes 9, greater than 6, so we must choose a smaller number. 2 2s are 4, and the square root of 5 is 5. Okay, 6 to 5, square root of 6 to 5 is 25. Similarly, the square root of 2 to 5 is 15. So we were asked to find the value of x, isn't it? Value of x is 15. I hope you got this. Now let us move on to the next question. 19, evaluate. This is question number 1 of 19 and this is question number 2 of 19. Okay, so we are asked to evaluate. Evaluate means we are asked to find the value of this given expression. So let us find the value of this expression. Log a to the base b into log b to the base c into log c to the base a. Okay, so log a to the base b we copy as it is, into log b to the base c we copy this also as it is, log b to the base c. Now this number log c to the base a, I take this number to the denominator. Okay, log c to the base a becomes log a to the base c. Okay, log a to the base b, if I take this number to the denominator, this becomes log b to the base a. It changes, the log and base changes if I take from the number from the numerator to denominator and denominator to numerator. Okay, so I hope you got this. We have done this, isn't it? Log c to the base a means log a to the base c. If I take this number to the denominator, this log and base changes. Okay, now this equals to log a to the base b into, we have log b to the base c and log a to the base c, and bases are equal. So if we have like this, log a to the base x and log b to the base x, if bases are equal, then we can write this as log a to the base b. Okay, if bases are equal, then we can write this as log a to the base b. So log b to the base c into 1 upon log a to the base c means upon, isn't it? Log b to the base c upon log a to the base c. Bases are equal. This means log b to the base a. Okay, log b to the base a. Bases are equal. So this is log a to the base b into log b to the base a means 1. Okay, log a to the base b into log b to the base a means 1. So we have already done this. I have made a separate video for this, rules of logarithm. Please find that video in the playlist and check out the rules of logarithm. Okay, so log a to the base b into log b to the base a, if log and base are opposite and they are being multiplied, then the resultant will be 1, because we knew here, isn't it? Log a to the base b equals to 1 upon log b to the base a. If we take this number to the denominator, this log becomes base and this base becomes log. So now if we cross multiply these two, log a to the base b into log b to the base a, then we get 1 in the right hand side, isn't it? So log a to the base b into log b to the base a equals to 1. So this is 1. Okay, so value of number 1, 19, question number 1 of 19 is 1. Now let us do question number 2 of 19. So we are asked to find log 8 to the base 3 divided by log 16 to the base 9, isn't it? So we can write this as log 8 means 2 cubed, okay, to the base 3 upon, divided means upon, log 16 means log 2 to the power 4 to the base 9. Now this 3 can be written in the front, 3 log 2 to the base 3 upon, this 4 can be written in the front, 4 log 2 to the base 9, isn't it? So 3 upon 4 into 3 upon 4 we have, okay, 3 upon 4. Now log 2 to the base 3, log 2 to the base 3 into, if I take this number from denominator to numerator, the base becomes log and the log becomes base, okay. So this becomes log 9 to the base 2, okay. 9 becomes base, this base 9 becomes log and the log 2 becomes base. So our 3 upon 4 into log 2 to the base 3 into 9 means 3 squared, isn't it? 3 squared is 9. So log 3 squared to the base 2, not or, okay, equals to 3 upon 4 into this 2 you can write in the front here, okay, this 2. Now we have into log 2 to the base 3, log 2 to the base 3 into log this 3 to the base 2, 3 to the base 2, isn't it? So 2 to the base 3, log 2 to the base 3 and into log 3 to the base 2, isn't it? Opposite, isn't it? Similar way as we did this in earlier case. Log a to the base b into log b to the base a. Log a to the base b into log b to the base a. Same thing. Log 2 to the base 3 into log 3 to the base 2. This is 1. This whole thing is 1, isn't it? So 3 2s are 6. 6 by 4 into 1. That is 6 by 4. So let me continue this here, okay? Equals to 6 by 4, isn't it? 6 1s are 6 upon 4. 6 by 4. So 2 2s are 4. 2 3s are 6. 2 2s are 4. 2 3s are 6. 3 upon 2. That this means 1 whole 1 upon 2. 2 1s are 2 plus 1 is 3 by 2. 2 1s are 2 plus 1 3 upon 2. This is an improper fraction, so we need to convert this into mixed fraction, okay? So this is the answer for question number 2 of 19. Let us do question number 3 of 19. Okay, now let us do question number 3 of 19. Evaluate log 8 to the base 5 upon log 16 to the base 25 into log 10 to the base 100, okay? So let us do this. We have log 8 to the base 5 in the numerator, isn't it? These two are in the denominators. So let us take these numbers to the numerator, okay? What happens? Log 16 to the base 25, isn't it? This log and base changes. So log 25 to the base 16. If we take this number from denominator to numerator, base becomes log and log becomes base, okay? So into this also log 10 to the base 100, isn't it? So log 100 to the base 10. Now this equals to log 8 means log 8, isn't it? 8 means 2 cubed, okay, into log 25 means log 5 squared upon 16. This is base is 5, okay? Log 8 means log 2 cubed. 2 cubed is 8. This base is base 5 into log 25 means log 5 squared is 25. This base is 16 into log 100 means 10 squared to the base 10. Now we have this equals to 3 we can bring in the front, okay, into this 2 also we can bring here, this 2 also we can bring here, 3 we can bring in the front, 2 we can bring here, this 2 we can bring here. So 3 into 2 into 2, 3 into 2 into 2 into log 2 to the base 5, log 2 to the base 5, okay, into log 5 to the base 16 isn't it, into log 10 to the base 10. Are you getting me? I hope so. This 2 is brought here, so this 2 comes here. This 2 is brought here, so it comes here. Okay, so this is 3 into 2 is 6, 6 2s are 12, 12 into log 2 to the base 5 into, now I take this number to the denominator, okay, 1 upon log 16 to the base 5. Base and log changes, isn't it? The 16 becomes log and this 5 becomes base, into log 10 to the base 10 is 1, so we need not write that. So 12 we write here, into log 2 to the base 5 into 1 upon 16 means 2 to the power 4. 2 to the power 4, log 2 to the power 4 to the base 5. 2 to the power 4 is 16. 2 into 2 into 2 gives us 16, isn't it? So let me continue here. So 12 into, this gives us 12 into log 2 to the base 5, log 2 to the base 5 into, okay, this 4 can be written in the front. So 4, 1 upon, okay, 1 upon 4 can be written in the front, 4 log 2 to the base 5, log 2 to the base 5, isn't it? So we can cancel this log 2 to the base 5 and log 2 to the base 5 because both are, one is in the numerator and one is in the denominator, isn't it? You can cancel here either, or you can bring this number to the numerator. This becomes log 2 to the base 5 into log 5 to the base 2. Same thing, log 2 to the base 5 and into log 5 to the base 2 becomes 1, isn't it? So either you do this way or you can straight away cancel here. Same number, log 2 to the base 5, log 2 to the base 5, one is in the numerator, one is in the denominator. We can cancel this, isn't it? So 4 1s are 4, 4 3s are 12. So this gives us 3, isn't it? Is the answer. So answer for question number 3 of 19 is 3. Okay, so let us do question number 20. Okay, let us do question number 20. We are asked to prove that, okay, show that log m to the base a divided by log m to the base ab equals to 1 upon log b to the base a. So let us prove this. Let us first write the left hand side, okay, LHS. LHS is log m to the base a divided by log m to the base ab. Okay, now log m to the base a whole upon, divide means whole upon, isn't it? Log m to the base ab, log m to the base ab. Okay, now what we do is we just interchange. Okay, this, when we do this, this m becomes base, isn't it? So we bring this number from denominator to numerator. Log m to the base ab, when we bring to the numerator, becomes log ab to the base n. Now if we take this number to the denominator, this base becomes log and log becomes base, isn't it? So log a to the base m, isn't it? Log m to the base a becomes log a to the base m. Now this is base. Okay, now log ab to the base m, log a to the base m, isn't it? So if we have like this, log a to the base x upon log b to the base x, if bases are same, okay, log a to the base x and log b to the base x, bases are same, then we can write this as log a to the base b. Okay, so this means log ab to the base a. So log ab to the base a means a into b, isn't it? Ab means a into b. Log a into b means log a to the base a plus log b to the base a, isn't it? ab means a into b, so log a plus log b, log m plus log n, isn't it? So log a to the base a means 1, log a to the base a, log of a number to the same base is 1, log a to the base a is 1 plus log b to the base a, log b to the base a, isn't it? So this is what we have in the right hand side, 1 plus log b to the base a. This equals to RHS, hence proved. Okay, Now let us move on to the next question, 21. Okay, now let us do question number 21. Log x to the base root 27 equals to 2 whole 2 upon 3. Find x. So this is the given equation. We are asked to find x. Okay, so let us first write the given equation. Log x to the base root 27 equals to 2 whole 2 upon 3, isn't it? Or we can write this as log x to the base root 27 equals to 3 to the 6 plus 2 is 8 upon 3. Now this is a logarithmic equation. Let us convert this into exponential form. Or this is base, isn't it? Root 27 is base. So we write base here, root 27 to the power 8 upon 3. 8 upon 3 equals to x. Okay, this x goes to the right hand side. Or root 27 means 27 to the power 1 by 2. Root under root 27 means 27 to the power 1 by 2 into 8 upon 3 was already there, so 8 upon 3 equals to x. So this 2 1s are 2, 2 4s are 8, or 27 means 3 cubed, isn't it? Into, so 1 is 1 into, now we have 4 upon 3, 4 1s are 4, isn't it? 4 upon 3, so we write 4 upon 3 equals to x. This 3 and 3 can be cancelled, or x equals to 3 to the power 4. 3 to the power 4 is, let me write this 3 to the power 4 here. Okay, so let me continue here. Or x equals to 3 to the power 4 means 81. Okay, 3 into 3 into 3 into 3, 3 to the power 1, 4 means 3 to 9, 3 to 9, 9 into 9 is 81. So we were asked to find the value of x, x is 81. Okay, now let us move on to the next question. Okay, now let us do question number 22, evaluate. So we are asked to find the value of this expression. Okay, so this gives us 1 upon log bc to the base a. So we are asked to find the value of this expression, isn't it? So log bc to the base a, log bc to the base a, we write as it is, plus this 1 can be written as log a to the base a. Okay, log a to the base a, log a to the base a is 1, plus this plus 1 upon log ca to the base b, ca to the base b, we copy as it is, plus instead of 1 I write log b to the base b. Log b to the base b means 1, plus 1 upon log ab to the base c, log ab to the base c, plus 1, instead of 1 I write log c to the base c. Okay, now this is 1 upon log bc plus log a, same base, isn't it? Bases are equal, a. So log bc plus log a plus log b, or log m plus log n, isn't it? So this gives us log bc into a. Bc into a is abc to the base a, plus 1 upon log ca to the base b plus log b to the base b, same base, so log m plus log n, isn't it? So log ca into b, log ca into b is abc, isn't it, to the base b, plus 1 upon log ab to the base c plus log c to the base c, means log ab into c, ab to the base c plus log c to the base c, bases are equal, so log ab into c, that is abc to the base c. Now what we do is we bring this number to the numerator. What happens? The base becomes log and log becomes base, so log abc to the base a becomes log a to the base abc. Okay, plus log, this also we bring to the numerator, log abc to the base b becomes log b to the base abc. Similarly, plus 1 upon log abc to the base c when we take this number to the numerator, log c to the base abc, isn't it? So log a plus log b plus log c, isn't it? Bases are equal, abc, abc, abc. If the bases are equal, then we can multiply this. So log a into b into c, that is abc to the base abc. So log abc to the base abc gives us 1. Okay, so this is the answer for question number 22, the last question from this exercise and the last question from this chapter, that is chapter 8, isn't it? So we have completed logarithms, and I hope you understood the concept of logarithms. So stay connected and practice well. Okay, I'll upload the next chapter in the next video. Thank you so much.